Hi, this is Chapter 1.1, Part 2 of Calculus 1. In this video, we're going to go through the use of formula to model applications and also how to find zeros of function, as well as some properties of graph of a function. So the first things is how we can have a formula and change into a function. So everybody knows that to find the area of a circle, the area is a equal to pi r squared. It's just a formula that I can use. Whenever I know r, I can find area. If I know area, I can find r. But now I can change it into an area function a of r. So remember, this is not multiply, but it's a function notation where I say if I know r, I would use this to find my area. A of r equal to pi r squared. We read it as A of r. R is the input. So to specify a function, we always look at what is the domain and range. So in this case, r has to be a positive radius, right? So it can anything from 0 and infinity, you can have the radius as large as possible. Range would be the area. It would also be from 0 to infinity for interval notation. Another very popular formula function is the height of an object during free falling. So whenever you let go of an object, so if you stand on top of a cliff or a building or something, and you let go of an object, it's going to go down because of gravity. And so it would be reaching the ground as much as possible according to time. So the reason why I have a negative 16t squared is because of gravity. The 100 is in the beginning how tall the object is. So first we would use this formula. S of t is equal to negative 16t squared plus 100 give us the height of the object after they fall for t second. Okay, so we'll find the time when the object hits the ground. So we don't know what t is. Find the time means t is question mark. But when it hits the ground, S of t would be 0, right? Hits the ground means it is over here. So we would say I'm going to have S of t equal to 0. S of t is on this side. So 0 is equal to, what is this side? It should be negative 16t squared. Suppose if I know what t is at 100. If I plug it in, it should give me 0. So solving this will tell us the time when the object hits the ground. So solve this, we'll do negative 100, negative 100. So I would have 100 equal to, or negative 100 equal to negative 16 t squared. Now divided by negative 16, divided by negative 16. So t squared would be 100 over 16. Negative and negative cancel. T would equal to square root of that, right? So we would have 100 over 16. Both of them are square number, square root of, so be square root of the 100 is 10, square root of 16 is 4, so equal to t. And that was equal to 5 over 2, or 2.5 seconds. So after 2.5 seconds, it's going to hit the ground. So we would say 2.5 seconds here. Okay. Find the domain of f as s of t. So this function can take in times any times we want, but obviously you would not need to know anything after 2.5 seconds. So the domain would be, what is meaningful for this is 0. I think you can do 0 in the beginning and 2.5, right? Because this is when it is starting and 2.5 is when it hits the ground. So this formula is good for that. So notice domain of a formula function is the set of input where the function is defined, known as the natural domain. So if someone write a formula out, there is a natural domain that will let you calculate some output. The next one we're going to look at is something called a zeros of a function. So if I have a function, there is some value of x that are special because when I plug in this, the output is 0. So these x value are called zeros of the function. And if we plot it, it would become y is 0, right? And this is f of 0. No, this is x. This is f of x is equal to 0. So this would be, this is f of x, such that the y is 0. And so it corresponds to x-intercepts of the graph. So in a graph, if you have all these graph of a functions, all these points would have the y equal to 0. So these are called zeros of a function. It's the x-intercept. Y-intercept is when x is 0, right? X is 0, and we call it the y-intercept. It's actually the value f of 0. You plug in x equal to 0. So zeros does not mean y-intercept. Zeros is x-intercept. So these terms, zeros of a function, are the x-intercept. So let's say if I have a formula functions, I want to find the zeros of it. And when we say 0, we're talking about real 0 because we usually use real 0 for graphing. They're actually the x-intercepts. So if I have x squared minus 3x plus 2, and I want to find when f of x is equal to 0, so I would solve x squared minus 3x plus 2 equal to 0. Solve f of x equal to 0. That means y is 0. This is y, right? Y is 0. So this one, I would do factoring to solve because it's a quadratic. So find two numbers. When they multiply, they are 2. When they add, they are negative 3. So it is negative 2 and negative 1. So I'd have x minus 1, x minus 2 equal to 0. To solve it, I split it into x minus 1 equal to 0. 0 product property, x minus 2 equal to 0. So x is equal to 1 and 2. So there's two x-intercept. One is 1, 0, and the other is 2, 0 for this function. Second one, I have a function is x minus 2 and x plus 5. So it's all factored out. You see how it is all factored out? So to solve for 0, I just write x minus 2, x plus 5 is equal to 0. So because it's already factored, I just split it up. That's 3 single linear function, x equal to 0, x minus 2 equal to 0, and x plus 5 equal to 0. Because whenever one of them is 0, the whole thing is 0. So this one is done, and I have x equal to 2 and x equal to negative 5. So the 3, 0 would be 0, 0, 0, oh no, 2, 0, and then negative 5, 0. So that we have 3 x-intercepts. So we have 2 more that we want to try. So maybe we'll go over that in class. Okay, so let's do the second page, which is some important properties of graph of function. It's increasing and decreasing intervals. So if I have a function, I'd like to know when x is increasing. What does increasing mean? That means when x increases, y also increase. That's called the interval where x is increasing. So now some function, the whole function x is increasing, but there's some function where it is increasing in some intervals and decreasing in some intervals. And decreasing is when x increases, y actually decrease. So it's easy to find increasing and decreasing interval if you have the graph. So let's read off how to figure out when it's increasing and decreasing. In this textbook, they give the interval in the quality notation, but I like to just give it as a interval notation. So look at when is it increasing is when you have a positive slope, right? So this is kind of like the increasing notations. So you can see that this part of the function, they're all going up, right? Going up. This side is also going up. From left to right is going up. Whenever x is increased, y also increase. So we'll say these two intervals are increasing. So start from negative infinity for x up to this point, negative 2. It's also increasing starting from 2 in here, x value 2, to infinity of x. When is it decreasing? Decreasing is, maybe I'll choose another color. Let's say red for decreasing. Okay. So be like, oh, I think it changed everything to red. And so this is decreasing. Okay. So decreasing is going down. So this is decreasing. That means when x increase, y actually decrease. So when is it? It's from -2 to 2. The x interval is from -2 to 2. So when people ask when is x increasing, when is it increasing, and when is it decreasing, you specify the interval of x. And when we talk about increasing and decreasing, we talk about strictly increasing, decreasing. Okay. So we're going to stop here, and then we will have part 3 about composition and